Hey everyone, my name is Luke, and I'm really excited to join you today because it's my favorite kind of day at Semgrep, which is a launch day, where we get to share the exciting stuff that we've been working on for the past couple of months. What I thought I would do is just start with a little bit of context on, hey, what is the company? What do we build? And where are we going? So our mission at Semgrep is to profoundly improve software security and reliability. And the reason why we think that this is such an important mission to go after is that software is eating the world, but it's really cheap to exploit. And we view that as a tax on society's development and progress. So we want to remove that tax and help society develop faster. Put really simply, the way that we think we can achieve this mission is by making it expensive to exploit software so that fewer adversaries can do it. And we ask ourselves a lot internally, hey, how do we do this in a way that accelerates development velocity, where, classically security, I think, can be modeled as a weight for developers. So that's the balance. Our vision for the product, and I guess for the company, is we want to be the world's best AppSec platform. And we want to do that in a way where we provide a simple and engineer-first suite of products that are really focused on security practitioners. So this could be security engineers, this could be software engineers, but maybe the kind of shared piece there is engineer. And we want to help those engineers actually find, fix, and prevent the bugs that matter in their software. Simple in this case to me means that it needs to work out of the box, right? We need to have good defaults, and it needs to be reproducible, something you can understand. Engineer first, this is our focus again on the practitioner, but also means that we want to work really early in the software development lifecycle. So you'll see that with the new product that we're launching today. And then also, we know that a lot of people on this call are engineers, and it turns out engineers can build things, which we love. And so we want to give you something to build on. That means good APIs, good output formats, and a real focus on the developer experience. I included enforcement before build time here as something that we're looking at. So we really do focus on source code and how we can help actually drive the adoption of secure coding practices. And again, that's to push us earlier in the software development lifecycle. So we'll have a Q&A at the end. If you have any questions about that mission or that vision, please feel free to ask. A quick overview, because I know there's a lot of new people on the call of the Semgrep ecosystem. I'm focusing more on the commercial side of our work here and less on the open source. So I do encourage everyone to go check out Semgrep open source, though. I think it's a really, really great starting place for your kind of journey with us. So at the core, we have Semgrep Cloud Platform. This is what lets you deploy, manage, and monitor Semgrep at scale. Turns out that once you have maybe 5 to 10 projects or repositories within your organization, it can get really difficult to manage security tooling on them. And so Cloud Platform is meant to make that easy and has all the core security workflows, the things that are going to be the same between products. And we offer 2 products as of today, I guess 3 once we do the launch. So we have Semgrep Code and Semgrep Supply Chain. And Semgrep Code is really designed for detecting vulnerabilities in the source code that you write. So this is for first-party code. And this differs from Semgrep open source in that the sophistication of the engine. So this one, for Semgrep Code, we can actually look across file boundaries and across function or procedure boundaries. That kind of data flow analysis is really key for actually finding vulnerabilities rather than enforcing kind of coding patterns. The other thing for Semgrep Code is that it offers rules that are maintained and developed by our security research team, and they're meant to be kind of high confidence rules that are appropriate for showing directly to developers. So that's the code product. On the supply chain side, the main thing here, so this is for finding vulnerabilities in your open source dependencies, which I think we all know can be very noisy if you're just looking at your manifests and import statements. So for Semgrep Supply Chain, what we do is we take our expertise in source code analysis, and we're actually checking not only do you use a vulnerable dependency, but are you using the vulnerable method? And what's great about doing this is that you get a 94 to 98%, it's a very high number, reduction in results. And you can really focus on, okay, we're actually focused on a truly vulnerable dependency that might impact us. What I love about our products and everything that I've just described is they're actually all free to use. So you can log in on semgrep.dev. You can start using these today. It's free up to 10 contributors a month. And I will share, I think this is me coming from a software engineering background. It grinds my gears when you have to talk to someone to try the product. So this is your chance. You can go use it. Again, engineer first, so you all know what to do. And that philosophy of simple and engineer first also manifests in how you consume and run Semgrep. So we have one binary. You can pip install Semgrep locally or in your CI/CD environment. You can also consume it via Brew or Docker, so meant to be developer friendly. There's one syntax across all of our products. So once you learn how to write custom rules and customize Semgrep when you're ready, you just learn once and can use everywhere. And there's one UI, that's Semgrep Cloud Platform. And so for us, these things all come together into a comprehensive code security platform. So you have code, which is SAST, supply chain, which is software composition analysis, SCA, the product that we're launching today. And I promise you, we have a lot more in the works. So we really pride ourselves at Semgrep on doing it fast and relentlessly improving. Over the last 6 months, there have been a lot of additions and improvements to the product suite. And I'm just going to highlight the ones that were big enough to make blog announcements. So starting off on our Semgrep Supply Chain product, we introduced dependency intelligence and license compliance. Dependency intelligence lets you actually search your dependencies. So let's say Log4j comes out, you can quickly look and see, hey, is there anything across any of my projects that I might want to go check? So you can actually do a search for that dependency. And for license compliance, this lets you enforce which licenses are allowed or are permitted within your organization for open source dependencies. So those were big adds. We also introduced our VS Code extension. All of our products work within VS Code, and this is on every single file save, developers will get results, and it really, really feels instantaneous. And that is also running locally on their machines, which is really cool. We have IntelliJ coming shortly. We also started to offer this unified product experience and are giving away all of our products for free, up to 10 developers a month. So you can go ahead and get started, particularly for small teams, or if you want to start with an individual project within your larger organization. We added Go to our Semgrep Code product. So this is our advanced analysis. We call it the Pro Engine, and a lot of rules that are only available for Go in Semgrep Code. For the Rust fans out there, we added beta support for Rust, which we love. And we've also started to experiment with AI with Semgrep Assistant. So what I really love about this is we still use our underlying code analysis to produce results. So that means that the results are reproducible and deterministic, which from a security point of view is something that I love and we talk a lot about at Semgrep. But then we take those results and we augment them with a little bit of LLM magic. And this is to suggest whether or not the result is a true positive or a false positive and provide additional context. And we'll surface that context to you so you know where to focus and which results to start with. There's a ton more that we worked on, but these were the big items that actually made the blog. So without further ado, I'll turn it over to Leif and Raghav to introduce our latest product, Semgrep Secrets.
Thanks, Luke. I'm Leif, and I'm joined by Raghav. And we're here to talk about secrets. So I'm sure a lot of you already know why having secrets in code can be a bad idea. Maybe some of you have been unlucky enough to have to deal with this problem directly. But for those of you that haven't, the lucky ones, some of the big dangers with having secrets in code is that repositories can become public. This can either happen through an internal project becoming open source or a developer accidentally copying a repository and making it public in the process. Either way, your secrets along with your code base have been shared. And if there's anything that's still active, even if it's in the Git history, malicious actors can find and use that secret. Last year, Toyota announced that a secret had been present in a public repository for almost 5 years. This secret could allow an attacker to see personal information from hundreds of thousands of customers. Maybe your security and infrastructure teams have spent months deploying something like HashiCorp Vault. Your developers may be undermining this work by having secrets stored in plain text in your code base. This also reduces adherence to least privilege because the folks that need to contribute to a code base often outnumber the people that actually need access to the production secret that might be in that code base. Additionally, coworkers often send each other snippets of code via Slack. Rogov sends me stuff all the time to get help with what he's working on. And then I send it to ChatGPT because I don't know the answer either. Now, if you have a secret that, Rogov has sent to me, it's in Slack. And then if I sent it to ChatGPT, now it's also out there as well. Secrets in code can also be copied by a disgruntled employee or an external contractor. Leaking secrets is really easy, and it can have grave security implications. And once a secret has ended up somewhere that it isn't supposed to, it can be really time consuming to figure out where it's used, who's using it, rotate it in all the places that it is being used. And if you miss something, this could cause a service disruption to your customers.
Awesome. Thanks, Leif. So let's talk about Semgrep's goals. Luke covered our existing product suite. We have Semgrep Code for SAST, Semgrep Supply Chain for SCA, and now Semgrep Secrets for Secrets. But how do we actually, what makes a Semgrep product? We have two main philosophies that we like to do product development with. First is we want to focus on detecting the issues that matter. And second, we want to focus on taking these results and being able to put them in front of developers in a way that reduces developer friction that they may encounter if they have to leave their existing workflows. So with secrets, how do we detect the issues that matter? We have kind of a three-pronged approach that we're taking here. The first is using semantic analysis. We couple that with validation. And the third is improved entropy analysis. So what is semantic analysis? Semantic analysis in Semgrep is not just understanding kind of what data exists, what credential exists in your code base, but it's actually going a level deeper and understanding how is this data actually being used. So variables that are used for authentication specifically are far riskier than those that are just, in the code base in a variable. And it's important in our secrets detection tool to be able to understand the how behind all of these credentials so we can accurately tell you, hey, this is something that is risky and you need to look at it more versus something that's not. And the beauty is this is unique to Semgrep Secrets. So in our Semgrep engine, we have really powerful data flow analysis, which makes the engine more context aware. This is something that a lot of regex-based scanners aren't able to do because they're just trying to match patterns. But leveraging Semgrep's data flow analysis and code-aware context, we're able to take this a level deeper and help you understand, hey, here are the results you need to focus on, and here's the context around why it's important. So let's look at this example. This is pgpool is a very common Postgres kind of connection library in the Node ecosystem. And we're creating a new client here, making a connection to the database. And of course, we see that there's a password that's hard-coded in this connection. And this is something that is going to be caught by pretty much any scanner, whether it's Semgrep or whether it's a regex-based tool. But the interesting thing here is with Semgrep Secrets, you get a little bit more context beyond just, hey, here's a password that is hard-coded. You actually get to understand how is it hard-coded or what is the impact of this credential being leaked. We know that Semgrep knows that pgpool is a connection to a database. And so we can say, hey, here's a hard-coded password, but the impact of this being leaked is that, somebody might get access to a database, which is much higher criticality than, say, something like, an internal service token or a Slack webhook. Here's a second example. This one really highlights data flow analysis. So we see that, we have this object, which has a bunch of different parameters. The one we want to focus on is on line 5. This is u.p, which is some password that's been generated by a user for the connection they're trying to make. The interesting thing here is regex-based scanners will probably flag this line if it was u.password because the variable name includes password. But Semgrep, again, we want to go beyond just regex. So how do we make sense of this information? We have u.p, it has this hard-coded credential, but what does this actually mean? We see that this credential is being used to create a connection to a MongoDB database. And because Semgrep is able to understand, through its rule syntax that, hey, the second parameter passed into this connection string is actually used for passwords. We want to check to see if that connection that's being passed in is actually hard-coded or it's being, maybe it's got from some environment variable, which is maybe a little bit safer. In this case, we can see on line 5, u.p is hard-coded. So we are flagging this to the user and saying, hey, this is something that you need to be aware of and watch out for because it's an instance of a hard-coded credential. The example I talked about, same example, but instead if we have something that comes from an environment variable,
we're a little bit safer here, and Semgrep knows that, hey, env.password123 is not coming from a hard-coded credential and actually is an environment variable. And so we won't flag this to the user, which is really important in, one, reducing noise, and two, being sure that what the results you show to developers have a very high signal-to-noise ratio.
For validation, the first step of verifying that a secret is still valid is finding it. And so the Semgrep command line tool is going to look for a secret, and the engine will identify, hey, this looks like a Slack API key. And then we're going to make a safe call to the Slack API just to see if this is still valid. And this is all happening locally within your infrastructure. You're not sending the secret to us at any point during this process. And then once we've verified that the secret is real, we're going to let you know so that you can prioritize finding the system owner, determining how it's used, and rotating it. This saves you a lot of time, because if the secret's no longer valid, you don't need to go through this effort of rotating it and finding where it's used and everything like that. In some cases, we may not have a validation rule, or we may not be able to validate a secret. These rules increase our breadth of coverage, but will require manual validation of any identified secrets. This is just a little preview of some of the tools that we already have validation rules provided for us that you can use immediately. And we're constantly adding both unvalidated and validated secrets rules to the Semgrep engine. Now I'm going to go through a quick demo showing what the command line tool actually looks like. As you can see here, we have a recently created GitHub personal access token, which I'm going to copy and paste into this local repository. After running the Semgrep secrets product, we'll see that I have one valid secrets finding. This means that the Semgrep engine was able to call out to the GitHub API and validate that the secret was still active. If we go ahead and delete this secret and rerun Semgrep, we'll now see that we have one invalid finding, which means that Semgrep determined that the secret was no longer valid. As you can see.
Awesome. And the last of the three, so we covered semantic analysis, we covered validation, and now entropy analysis. So what is entropy analysis? It's really just a measure of how information is encoded in a string. You can think of it as a test of randomness. Basically, how random is this hard-coded string in my code? Most open source entropy analysis is noisy, resulting in a lot of false positives. And Semgrep open source, I think, also is included in this boat. We do have a form of entropy analysis in Semgrep open source. But if we look at this example here, this is something that Semgrep open source would flag as, high entropy. This is a common UI placeholder that is used in C# development. The interesting thing to understand about entropy analysis is that it is generally the catch-all bucket for unstructured credentials. So in the validation example Leaf gave with GitHub, GitHub tokens are generally prefixed with, GHP underscore or GHA underscore. And so it makes it really easy to identify those credentials as coming, being from GitHub. And that's how we're able to perform these validation checks. Many services, however, have unstructured data. They necessarily don't have some sort of prefix, or in the MongoDB example even, right? We saw that it was just kind of a randomness of letters kind of stitched together. So how do we detect kind of, the 70, 80% of credentials that maybe aren't structured in some way? This is where entropy analysis comes in. So you're able to say, hey, given this, hard-coded credential, what is the mathematical randomness of this credential? And if something is very structured, like we see here, text CFM password, even though the name password exists in the string and in the variable, it is prone to many false positives. Whereas leveraging Semgrep secrets high entropy analysis will kind of say, hey, this is not really that random. The likelihood of it being a generic API token or some generic credential is pretty low. And we want to save security teams and developers from having to sift through all of that noise. Beauty is, with improved entropy analysis, you get better results for developers. So instead of showing them 1,000 things that they're probably going to end up ignoring, and the 1,001st thing that they look at is maybe real, but they're so used to ignoring things. With entropy analysis, high entropy analysis, and Semgrep secrets, you're able to surface them really just the issues that matter, so they know that when they get a result from Semgrep, it's something to look at. Drake is a big security fanatic, so he kind of gave this, math, security, computer science explanation of entropy. It's great. We hope to have him in one of the future webinars sometime soon. So we talked about, cool, this is how you detect credentials, surface results that matter. But the second part of that, it's kind of pointless if you have a list of 1,000 things to look at and this backlog is growing and growing and growing. The really important part here is, hey, once you detect these issues, how do you put them in front of developers in a way that is really conducive to them fixing these issues, while also not taking them out of their existing workflows? Developers hate, logging into 5 different web applications to kind of fix one issue, slowing them down. How do we get these issues to them in real time, in the context that they're already working in? So Semgrep is great for surfacing results and pull request comments. So you create a PR, you get a comment right there, seconds after you've committed the code. You can get in a pre-commit before even committing a certain credential, which is really key for secrets. We know that the effort from, the point at which you commit a secret, the effort to detect it before is 10 times less than remediating it after it's been committed. And this is true of the IDE integration too. And you can see an example here of what that looks like, where a developer might even just be testing out, making a request to GitHub. And we want to just remind them, because it's very easy to make the mistake and kind of commit it and forget about it. But remind the developer, hey, this is a hard-coded secret. You don't actually want to commit it. And here are kind of the issues if you do decide to do it.
In the last video, I walked you through the Semgrep command line interface, and now I'm going to show you a little bit about the web interface. On the left-hand side, we have various filters, including the validation filter. So if you just wanted to take a look at the secrets that were confirmed valid, like the one that we created earlier, you can do that. From here, you can click into the details page. For folks that are familiar with our code product, you might recognize the rules down here. This is what was used to actually identify the secret in the first place. For some secrets, we also have revocation instructions, which makes it easy for your organization to rotate the secret and reduce your risk. And then if we go back to the secrets page, we also have some other filters. So if you wanted to only look at this other project, Leaky Repo, which is a publicly available secrets benchmarking repo, you could do that. And then you could also apply another filter here to just see the things that are associated with NPM. In the last video, I walked you.
Awesome. So to recap, semantic analysis, again, goal number 1 is surfacing issues that matter. With semantic analysis, we're able to go beyond just regex and actually leverage code context to contextualize the results you see, surface results that would be missed by traditional scanners. Second, validation. So out of the 100 things we surface, how do we actually prioritize the top 10 things to look at? This is where making requests to the actual GitHub APIs, Slack APIs help in this process. And third, with entropy analysis, there's a whole class of credentials that are unstructured. How do we make sure that the ones we do surface have a low false positive rate and are actually very high signal to noise ratio? Combine these 3 for detecting the issues and package them together, and you're able to surface these results directly to developers to make sure that they're remediating these issues in real time. And you can kind of manage, in large organizations, especially the problem that is secret sprawl. So detect the issues that matter, surface them frictionlessly to developers, and you have a happy security team and you have a happy development team. So thanks, everybody. To stay up to date with secrets, here are a few links to follow. We're really excited to have launched secrets today in a private beta. So please go ahead and register at the link there. There's a blog post kind of explaining a lot of the topics we touched on today. And we have a couple in-person roadshows that we're doing today. We have one in San Francisco. So if you're in town, we'd love to see you. And then in a couple of weeks on October 3rd, we have one in New York. So if you're based in the area, we would love to have you at either one of the events. So thank you. Thank you again.
Just to recap again, stay in the know. We have a private beta live now, so you can request access in the link. So go to the link right there to request private access. go.semgrep.dev/secrets.beta. Check out our blog. It just came out this morning. So if you want to learn more about the secret stuff, definitely check it out there. And if you're in New York or SF, we have in-person meetups and /roadshows happening. SF's happening today. So if you're in the SF area, we'd love to see you there for the training. If not, we have a happy hour. Drinks are on us. So feel free to join us for that as well. And with that, I think I'll wrap things up. Thanks everyone for joining, and we hope to see you at the next webinar.
Yeah, thank you.
Thank you, everybody. Appreciate it.